Now let's see problem 2. A body starts with an initial velocity of 10 meter per second and moves along a straight line path with constant acceleration. When the velocity of the body is 50 meter per second, the acceleration is reversed in direction. Find the velocity of the particle as it reaches the starting point. So see, let us by the figure. We are given that a particle is starting with the initial velocity of how much? 10 meter per second. So say I am taking the starting point at O, and here I am starting the stopwatch, and this is the initial velocity, how much? 10 meter per second, and moves along a straight line with some constant acceleration which is not given. So say A naught be the constant acceleration. Okay, so of course when the particle is going under the influence of the constant acceleration, what do you think? Its speed would be increasing, correct? And at some point it is given when the speed is how much? Say this is a point A, and here the speed is VA 50 meter per second, then the acceleration is reversed in the direction. Now see the language. It is given that the acceleration is reversed in the direction. That means the same acceleration is reversed in the direction. It means the magnitude of acceleration is not changing, only the direction is changing, correct? So after reaching the point A, the acceleration would be towards the left side with same magnitude A naught, correct? So say if this time is t1, so beyond t1, A will be towards the left side, okay? So it is going retardation, correct? So if it is going retardation, so we know the fundamentals. Now the velocity will be decreasing, and ultimately a point will come, say a point B, where the velocity of the particle will become 0. Got it? Now what will happen? Now the reversal of motion will take place, and the particle will start moving towards the right side with increasing speed, and ultimately it would be crossing again A. And can we say by symmetry? Because you see, from A to B, going from A to B towards the right side, and then from B to A towards the left side, the acceleration is constant. So when the particle is coming back to the point A, it will have how much velocity at A? Magnitude will be same, 50 meter per second, and the direction of velocity in the reverse direction will be opposite. So can we say the velocity will be 50 meter per second towards the left side, as it is moving with the same acceleration from A to B and from B to A. And you can also get it equation. If you see, you are taking this whole interval as one segment of the equation of motion, that is A to B to A, and if you apply V is equal to U square plus 2AS, so S is coming to be 0, A is constant, A is what? If I am taking this side as positive, so A will be minus A naught. So V square, this will be 0, will come to be U square, so V will be what? Plus minus U. So you are getting two values of V, and that is natural because at this point there will be two velocities. One will be along the positive side, one will be along the negative side, correct? So while coming back, it will be on the negative side with same magnitude, 50 meter per second. And this is also very basic, which we did a lot in the fundamental lecture. If particle is moving under constant acceleration and the reversal of motion takes place, the motion is symmetric, correct? And also this is very fundamental, as we have seen so many times in fundamental basics of kinematics, that whenever the particle is moving under constant acceleration and the reversal of motion is taking place, so the motion is symmetric. It means the time to go from A to B is same as the time to go from B to A. The speed at A in both the segments when the particle is going from A to B and from B to A will be same. Of course the velocity will be opposite. At A, here it would be 50 meter second like right side, and here it would be 50 meter per second. Okay. Now what will happen subsequently, because still it is moving under A naught, correct? So your speed will be increasing, and when it would be crossing the origin, it will have some velocity, say VO. Now don't get confused that here if it is 50, it is coming 50 by symmetry. So here if it is 10, why not it would be 10? See, Here it is symmetry from A to B, because here the acceleration get reversed in the direction. Can you see? So when the particle is going from A to B and B to A, it is moving under constant acceleration, meeting the condition of symmetry. But when it is going from O to B and B to O, then the acceleration is not constant. Can you convince yourself? When the particle is going from O to B and B to O, then the acceleration is not constant, because O to A, the acceleration is towards right. From A to B, it is towards left. From B to O, it is towards left. So you can't say that motion will be symmetric from O to B and B to O. You cannot apply that logic here, okay? VO, say this length is L. Now if I apply the equation of motion from O to A, say V square is U square plus 2AS. Okay, so V is plus 50, U is how much? Plus 10. A we don't know, but let it be plus A naught, because it is the right side, and your displacement is how much? Plus L. So I'll get 50 square is 10 square plus 2AL, correct? So therefore the value of 2AL come to be 50 square minus 10 square, that is 50 plus 10 into minus 10 is what? 3 multiplied by 3. So I'll get 2400. Okay, unit of course. I'm not writing unit right now. It will be the unit of acceleration multiplied by length. So 2AL has a numerical value of 2400. This we got. I'm not finding A and L separately, okay? If it will be okay. Now the same equation from A to O in the backward journey. So if I'm applying the same equation from A to O. Now see, from A to O, what will be U? What do you think? What will be the initial velocity with proper sign? We cannot change the axis. The axis is, positive axis is towards the right side. So we have seen the velocity at A is 50 meter per second left side. This will be minus 50 meter per second. What is the final velocity? That is VO. That is the unknown subject which we need to find. What is the acceleration? That is minus A naught. What is the displacement? So again it is covering a displacement L, but towards the left side. So it would be minus L. If you want the equation, V square is U square plus 2AS. So what I will get? V is what? V naught square minus 50 square plus 2 minus A naught into minus L. So I'll get V naught square is 50 square plus 2AL, correct? And you can put this value of 2AL in this equation. So I'll get 50 square plus 2400. So V naught square will come to be 2500 plus 2400, that will be 4900, correct? So your V will come to be how much? So your V naught will come to be under root of 4900, and this will come to be how much? 70. And of course it can be positive or negative, because velocity can have both sides. Now you have to decide which sign will be taken. So when it is going back and crossing O, so the velocity is towards the left side, correct? Velocity is towards the left, and taking the right side as positive. So according to your axis, the answer will be minus 70 meter per second. But while reporting the answer, you won't write minus 70 meter per second, because that depends on the choice of the axis, correct? If somebody is taking left side as positive, his answer would be plus 70 meter per second. So we will write the answer in terms of the magnitude and direction. So we will write the answer as 70 meter per second, okay? And opposite to initial velocity at t0. You can write the answer like this: 70 meter per second opposite to initial velocity at t0. It means if initial velocity at t0 is towards right side, then when it is crossing again the starting point, the velocity would be 70 meter per second towards the left side. So that is the answer to this problem.